Two Stuart major beam engines in the workshop. In this video I show the differences between two engines. They are both Stuart major beam engines built using Stuart Models castings, but the finished build quality is very different. The best way to view a model is like this before it's been painted, and as you can see it's very well machined. It's only when you look closely that you see there are one or two problems. It runs well enough and it sounds well, but let's look closer.
I featured this engine in a video some time back. It's been in my workshop now for well over a year, and finally I thought I'm going to have to get it done. It's just been sat there on the bench gathering dust. The video that I featured this engine in a while back was all about how not to buy a steam engine and what to look out for. And it's not to be confused in any way with the absolutely beautiful Stuart major beam engine built by Mr. Derek Fitzgibbon, who is a master craftsman. So while I've been trying to speak with my very bad cold, you have been watching some footage on screen showing some of the faults. And the first one, of course, is the beam is off centre. The second one is the pivot for the beam is off centre. And the third one is that the flywheel's all over the place as well. Now, I'm not sure whether this is due to the crankshaft or a badly machined flywheel. Here I'm waving about the pedestal that this bearing should be resting on. But sadly, instead of using this correct part, the entire engine is just fixed to this rough looking box. Here I'm looking at one of the main bearings, the one that's supposed to be on the pedestal. What I'm going to do is loosen up this bearing and wobble it about and see whether it makes a difference to the concentricity of the flywheel. So now, as you can see, I can move this bearing about and see what happens at the edge of the flywheel. One thing that worries me about this engine is the fact that a flywheel of this size, and it really is quite huge, is just pinched to the crankshaft with a simple grub screw. I would have at least expected a keyway. But anyway, by moving the bearing about, I can change the concentricity slightly of the flywheel. But initially it's not looking good. It really does feel like it's not a tight fit on the crankshaft to start with. And the same goes for the pulley wheel. That's wobbling about also. Now, is the crankshaft bent? Is it just too small for the flywheel? This could be a slight problem for me, because this large flywheel will not fit in my lathe. Plus it appears to have been slightly over machined. There isn't too much material left to remove if I do need to true up the flywheel. So for now I'll just nip up the bearing so that it doesn't work completely loose and drop off. And now again, as you can see, as I tighten down the bearing, the concentricity of the flywheel gets worse. I'm going to have the whole thing in pieces and have a close look at it in due course. Here I'm just having a play with the bearing. I've slackened off the nuts again, and I'm going to tap it with a hammer to see how far it moves. And as you can see, I am of course using a soft hammer to avoid damage to the bearing. And it moves a fair bit really, and the flywheel's concentricity changes very slightly. Yes, this is definitely going to be a problem. Throughout the video you've been seeing these spinning rings. These are showing problem areas on the engine. And here's a problem area. This is the bed plate, and it's badly machined. I don't quite know what's going on here. It's getting curiouser and curiouser. On the surface the engine's very well made, but it's not gone together very well. So with the help of my plastic boxes and my hammer securely away in its box, I'm about to take it apart. This is a short video about a beam engine. To be exact, it's a Stuart Models major beam engine, and it was built by Mr. Derek Fitzgibbon of Runcorn in Cheshire, England. This engine is absolutely beautiful in every way I can think of. The engine is not even run in, but still runs quite slowly. As you can see by the black oil residue, the bearings are wearing in quite well. The flywheel was machined by someone else with a larger lathe, but everything else was done by Derek. Just look at the quality of this Watts parallel motion. Making Watts parallel motion to this quality really takes some doing. There are lots of parts to make. Time to speed up the engine now. The idea of speeding up and slowing the engine down gives a nice even running in period. It will take quite a while. Although the engine is not particularly stiff, everything's quite free. And the sound is wonderful. This engine is so well made, it does not emit knocking or banging noises at all. Just the hiss of the compressed air escaping and the whirring of the gears driving the governor. The water pump is fully functional also, and these two fittings on the base allow connection of some silicone rubber pipes to circulate some water. There is more to engineering than just machining parts, of course, and the fitting of this engine is also exemplary. If you have a look closely at the parts, play the video a few times, you'll see the lock nuts all over the place to stop the fixings working loose. Once this engine is fully running, I would expect it to run down to about 10 revs per minute. At the moment it's still going quite fast, but each time we run it, it seems to get better. And once the oil runs clear from the bearings, we'll be getting somewhere. There really is not much more I can say about this engine that is not obvious. Engines like this do not come along very often. It is exceptional. I congratulate you, Mr. Derek Fitzgibbon. You're quite an engineer, and I love the engine. Very well done.
Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.